let's remind ourselves, we saw it at the end of chapter 4. What's the general form of an ester? This is the general form of an ester. When you have the CO2 bonded like this in between two hydrocarbons, it doesn't matter what two hydrocarbons, that's in the family of molecules called an ester. Okay? In this reaction, we're going to hydrolyze this. We're going to break this bond right here. That's an important thing to know. Which bond do we break? Lyse, break. Hydrolyse, break with water. So this bond will break. Here's the water molecule that's going to react with it. Notice I've made these slightly different colors. This OH is the green and this H is yellow, because we're going to keep track of those and see what happens here. So step 1, you break that. Okay? I'm going to back up the animation, show you again. In hydrolysis, the first thing that happens is this chemical bond breaks. Remember, chemical reaction, you're breaking old bonds and or making new bonds. So that bond breaks right there. What happens now is the OH from the water, right? Water H, OH, the OH, I have it green here, is going to form a bond right there. And the H is going to form a bond right there. Let's back it up and look at it once more. We break this bond in the ester. The OH from the water goes here, and the H from the water goes over there. Now, you may recall from chapter 4, this is the general form of a carboxylic acid, right here. Can anyone tell me what class of molecule that one is? No? What? No, what the class of molecule? What? Alcohol, yeah. When you have a hydroxy group on a hydrocarbon, that's an alcohol. So you make a carboxylic acid and an alcohol. Now, unfortunately, there's one more step, a little complication to this reaction. And we're not going to learn exactly why that is until we get to chapter 9. So what I'm going to tell you about it now is what I want you to know for now about this is a carboxylic acid can exist in two different forms. It could exist in what's called its acid form, when that hydrogen's on there, or it could exist in what's called its base form, where the hydrogen's not on there. Okay? This reaction, when it's catalyzed by a base, remember the OH I showed you in the first slide, if I go back here? Remember that OH, that tells you that this is what's called base catalyzed. When that's there, when a carboxylic acid is in a solution that has a bunch of OHs, we call that a basic solution. The hydrogen comes off, and it exists not as the carboxylic acid, but as the base form. We call that a carboxylate ion. So that's what we're going to see here. So you have a carboxylic acid, can exist one of two ways, as the carboxylic acid form, or when that hydrogen comes off. Notice you have oxygen with just one bond going to it, so you have that formal charge. You can get the carboxylate ion. That's the carboxylate ion. So carboxylic acid exists as the carboxylate ion when there's OH around. You're going to learn more details about that in chapter 9. But that's what I want you to know for now. In chapter 9, you're going to learn where that hydrogen ion goes. Notice the hydrogen ion came off and left its electrons there. It came off as a H+. For right now, it went into some hole in the universe. We'll talk about where it went in chapter 9. That's why when we first saw the first example of a reaction, the product was a carboxylate ion and an alcohol. I want to review this for you guys once more. Give you now the bigger picture. You start with an ester and water. We do the hydrolysis reaction. We break this bond. The OH from water goes here. The hydrogen goes here. In the case of a base catalyzed reaction, we got to do one more thing. We got to take that hydrogen off and put it in a hole in the universe. So immediately, the hydrogen comes off, and you get the carboxylate ion. So at the end of the reaction, you started with an ester and water. You end up with a carboxylate ion and that alcohol molecule that we made. The exact nature and name of the carboxylate and the alcohol will depend on those hydrocarbons that you initially started with.